So, thank you for listening my talk. We'll talk about today. No? Okay, perfect. We'll talk about the outcome of our research we made on Palo Alto GlobalProtect client, not the server side, but only the client. So I just show some CV, but you will see we have some other one. So for that, I was not alone. So a quick introduction about myself. I'm Maxime Escourbiac. I'm currently leading the Michelin Red Team. So as part of the Red Team, we do a lot of vulnerability research on the tools we will use on Michelin context. So for that, I was not alone. So I was helped by Yacine Bengana, just left us last week to join DoyenSec. So long life to Yacine. So that's it. So just this schema will try to explain briefly how Palo Alto GlobalProtect works. So the client can be split in two parts. The first one is Pine GPA. So basically the UI, when you can configure the portal URL, giving some user configuration, etc. It's the stuff you have in your laptop when you try to connect. We have Pine GPS, because obviously when you manage VPN traffic, you have to be with the high privilege. So there are services behind that. On server side, we can split in two parts: the portal, which gives the configuration, etc., and support all the authentication process, and the gateway, basically the IKE servers. So when we try to log in to your VPN using GlobalProtect, the first step is to get the DNS configuration from your laptop or DHCP. Then you try to connect to the portal. The portal, according to the configuration, the VPN configuration, will ask you for a username password if you use the integrated authentication mechanism, or, like Michelin, delegate the authentication to IDP. So for that, PineGPA will start an embedded browsers to, having the website, IDP website display. Username, password, OTP, if it's well configured, getting the authentication token, send it to the portal and get the configuration. The configuration gets some details about how the VPN have to work, including the gateway. The gateway is, in fact, you can, have a single portal and multiple gateway according where you are. Maybe you have some gateway on Asia, on US, on France, etc. So there are some other tools, but for this talk, I don't explain it. So, no surprise, I will begin with the attack scenario. So, in fact, we have, let's say, good network engineers in Michelin, so they applied hardened configuration. So, a client will connect to a fake AP access point, Wi-Fi, but we'll see later this can work with anything else. We the GlobalProtect, takes the DNS configuration from our AV access point. We poison some DNS entry, bypass certificate validation, we'll explain this later, install evil root certificate authorities, and then refresh connection and deliver HTA payload to compromise the workstation, and then having LPE, local privilege escalation, to have the full compromise. So, firstly, I will explain the RCE part, and secondly, I will explain one of the local privilege escalation possible. So, we performed the pen test in January 2024, so we have some discussion with Palo Alto, long discussion with Palo Altos, and they came back with 8 months later saying, okay, we have assigned a CV for you. Okay, perfect. We are happy. Drink champagne, etc., etc. And when we discovered the advisory from Palo Alto's website, there are some collision. They said, thanks, Maxime Escourbiac and Yacine Bengana and Amber Wolf security team to discover these vulnerabilities. Okay. We were surprised because we are not aware of that at all. So Amber Wolf, because Michelin, we are not vulnerabilities researcher. We don't try to sell vulnerability research to someone. So we don't prepare any blog post, etc. We try to keep maybe secret because we are not still safe yet. So they wrote a a blog post. And when we read the summary, we can see, by default, users can specify arbitrary endpoint in VPN client, etc. So we laugh a lot because, in fact, they need social engineering for this one. So in our case, we don't need social engineering, and when we read the details of the blog post from Amber Wolf, in fact, it's not the same vulnerabilities. Okay, the story remembers Amber Wolf blog post, not us. So it's not okay. It's okay. So let's come back with the embedded browser ecosystem. So when you try to connect with your IDP, this browser is appeared. So for maybe I saw a lot of young people here. So basically, this web browser based on Internet Explorer libraries. Yeah, for sure. Internet Explorer is no more present in our laptop, but all the DLL and all internal components can be still reachable using, for example, .NET stuff, etc. So I'm not that young, so I remember all the things that Internet Explorer can allow us. So the first cool stuff enabled with this embedded browser is ActiveX. So it's okay. I didn't see anyone lay down on the floor and cry, so it's okay. So just for the young people, this is why we developed ActiveX components. Yeah, I think IntelliJ was pretty much cooler than that. And if you remember well, the security configuration is managed with that toolbox. So you can set up some configuration according your network zone, internet, local network, etc., etc. So with some burp configuration, etc., we validate that, ActiveX, the embedded browser try to execute some ActiveX components. So this one is not works because it say the publisher is not, the ActiveX component is not assigned, but it's okay. Not a big deal when we can manage and insert some evil certificate authority. We can sign what you want, but we try to avoid to develop some malicious ActiveX component because we are lazy, and we only have two weeks for this pen test. Another cool things, maybe for blue teamers here no more, it's HTA. So HTA, it's kind of technologies embedding HTML and some scripting, so VBScript and JS. So JS was not for JavaScript, for JScript. So look like similar, but it's not the same. And it's executed with mshta.exe application. And in fact, now you can configure your embedded browser to make a sandbox, but you can perform some command execution, read file, write file, etc., etc. So here, just a calculate pilot for HTA, so it's a hello world generated with ChatGPT because we are still lazy here. So we succeed to execute some command directly with HT. The main issue is that the portal and the IDP is given by the portal, so we cannot, as external users, as external element from the workstation, we cannot change that URL. It's not possible. So as we detect, one solution we try is to poison DNS entry to say, login.machine.com is not on on our server. So just some configuration. So it's not a big deal, if a big risk for HTTPS traffic, because if someone try to poison the DNS, your Chrome, your browser will prevent you to go deeper. It's quite different on the embedded browsers. So normally we make a benchmark on the other pipeline clients. Normally they have a allow list for DNS. So they allow, for example, your company DNS, maybe some Google DNS, etc. Normally, you should not trust any random DNS configuration from a DHCP. Okay, so we say to the client, we are the gateway now. So firstly, initially, when we try it, the UI just display a quick warning and say you want to proceed anyway. So it was the first exploit, and we said, okay, fine. If you lock people to works, obviously they will click. I don't know your statistic on phishing on your company, but I'm quite sure if we block people to access to their favorite website, company website, they will click on the warning and exploit it. So Palo Alto, when we talked to Palo Alto with that, they say we have a configuration for that, and we prevent users to bypass and to say it's okay for me, I take the risk. So we have this kind of issue, and the server certificate cannot be verified, etc. So we are a bit sad for that. So we go through the code with Ghidra, and we try out how the client check the certificate. So we are a bit surprised. There are string comparisons of pre-login.esp. And when we see that, it's on the last day of the assessment, they say, no, come on. And that's true. They just check the certificate only for the first attempt to reach the servers. So, here a quick workflow diagram. The client make a pre-login request. The portal gives the SAML request to send to the IDP. So this one is well secured, so you cannot bypass the certificate, make stuff on IDP, and for the get config.dsp, in fact, the certificate is not checked. Okay, fine, we detect that, but how we can exploit it easily with a code is something we never done before. Just by counting with a little Python script, by counting the number of connections. So we assign an IP, and we detect the first tick is just the pre-login, the second tick, etc., etc. And when you reach the fourth request, we redirect the traffic to our evil gateway, evil portal. Sorry. So it was fine. So the client did not see anything. So we talk about injection. Amber Wolf explained well. In fact, in the configuration given by the portal, you can provide some certificate authority, and the PAN GPS will install it directly on the local machine certificate manager. So perfect. In fact, with that Python exploit tool, we are able to insert evil CA certificate authority stuff. So when you try to refresh the connection, in fact, if you directly redirect and poison the login.michelin.com DNS entry and redirect to our website, we are able to give the HTA exploit to the embedded browser and trigger the calculate. So just a quick demo before going to the LPE. So yeah. So just some demonstration about, we successfully poison the portal URL. So it's okay. It's on your local networks. Just verify that we don't lie and there are no certificate authority before the exploit. So the pre-login step is made and redirect us to our IDP. So writing password and validate the second factors. Redirect to the portal and our exploit works. Yeah. We are quite long. And that's it, say, yeah, you are well connected, etc. Not so well, but you are connected. And if you check the certificate, the cert LM, you can see that a new certificate authority has been added here, evil cert. So yeah, banco. Once we refresh the connection, we try to reach our IDP connection and then get the calculate. So it means that you believe you are protected with your VPN, but in fact you are executing some random code. I hope you don't connect to my AP access point right now and using. I'm joking. So the second part is, we have the RCE now. It's cool to have the local privilege escalation directly after that. So, as we discussed, pan-GPA and pan-GPS directly communicate using TCP on the port 4767. It was an encrypted channel, so it used OpenSSL stack for IS stuff with null IV and a static key. Repeated twice because it's more secure. So as we only have 2 weeks, we didn't have the time to reverse the whole process and how the key is generated. With our observation, we detect that the key is not similar within each workstation. So Rotary Drone make a great article to how to decrypt all the cookies inside file on the workstation. If you have some malwares getting some stealers and having and reading file, you can use them to connect to the VPN. But we are lazy, as I said. So in fact, we put a breakpoint directly on the OpenSSL routine and get the key. The TCP, in fact, it's just only XML message sent by pan-GPA to pan-GPS. So there are a lot of possible message we can send. So we focus only on check update and upgrade method. But there are a lot of attack surface, and I'm quite sure there are a lot of LP remain due to that. So we develop an exploit. You say we have the key, we have the number. It's okay. We can run evil message.exe, and we can communicate with pan-GPS easily. Unfortunately, pan-GPS block TCP traffic from other applications. The code to block is quite simple. He just look at the origin of the socket, and it's matched with C program file, Palo annotated works, pan-gpa.exe. So, as we are simple users, we cannot interact and modify the exe, let's say. So, shadow move save us. In fact, shadow move is to abuse the WSA, duplicate socket W, routine to duplicate a socket, and as the schema works, having a separate binary using that socket to communicate directly with pan-GPS. So the second version of the exploit, we succeed to send arbitrary message. The second one, by observe how the update and upgrade mechanism works, they made some impersonification. So we know impersonification can bring a lot of vulnerabilities because you have to validate the origin, the message, etc. So we reverse that function, and we detect that it check all the process run by the users. So, for example, if there are some users running pan-GPA, okay, let's take this user and impersonate him to delete some file, etc. If pan-GPA is not working, it check explorer.exe for impersonate. And if pan-GPA did not detect any pan-GPA or explorer.exe process, in fact, if it's a soft failure, is not impersonate anyone, and run as an anti-authority system. So yeah, it's beginning to be interesting. So the update mechanism is quite interesting because, in fact, pan-GPS did not make any HTTP request. All the HTTP request is made by pan-GPA. For me, it's a weakness because, you can manage, and you can, as you are a user, you can debug and put some breakpoint to modify the URL, etc. It's not so simple. So, pan-GPA will get the last version number from a URL on the portal. Pan-GPA will download the MSE file from Palo Alto S3 bucket, and pan-GPA say, hey, I have this version, please update. So pan-GPS is well made, let's say, for that. They verify the signature of the MSI file. if the signature is valid, and the certificate issuer is Palo Alto Networks. They copy the installation file to the program file Palo Alto Networks folders. Then impersonate the users that run PanGPA and delete the original MSI file. Interesting. After the move, PanGPS check the signature again, and if the signature is valid, install the MSI. So in red box, we see impersonate the logged on users and try to delete. Wow, interesting. So another tricks is based on the James Forshaw works again, because each time this guy publish a blog post, it's always a source of new vulnerabilities on Windows. So this one is well made. And Abdel Hamid Nasseri made a vulnerability report to ZDI, say one service, I don't remember the name. We are able to arbitrarily delete some file as admin users, and I succeed to turn it to local privilege escalation. So I will not explain because I think it's another slot for a talk. But you can abuse arbitrary file deletion to have local privilege escalation using that tool. We are able, with all the elements I present, I was able to develop the full exploit. So we retrieve the encryption key from PanGPA. Okay, this was fine. So retrieve from debugging or directly use the last article from Rotary Drone to generate it. Hijack the TCP socket with Jado Move. Kill both PanGPA and Explorer.exe to validate the soft failure for impersonating users. Getting the SIM link, because you remember in the process, PanGPS verify the signature before delete it. So we use the SIM link with OPLock. We run the ZDI exploit to prepare the file deletion to the system primitive. We send an update message to PanGPS with the generated SIM link. PanGPS check the good MSI file, installation file. We switch the swim link to the evil MSI folders with OPLock. We have a race condition here, but we succeed to perform it. The ZDI exploit is rugged, and we enjoy. So it was not the only one LP. In fact, you have several CV we discovered. There are so many behind that, and we stopped the count because, in fact, with initial report, with some exchange, say this one is already known, etc., etc. We lost the wire. In fact, we don't know really which one is solved, etc. It's a complex mess. So, as a timeline and a conclusion, as I said, we make the pen test in January 2024. 2 weeks assessment. We begin to communicate. So you see a lot of stuff on the left side of the timeline. Waiting a lot from Palo Alto's because they improve a lot their responsible disclosure policy. Now they have a bug bounty. So feel free to find some bugs in Palo Alto GlobalProtect to earn some money. And we have some CV just published in August this year. So 1 year and a half after, it was a regression because some developer from their side forgot to apply some hardening configuration, and that's it. So the current patch. I write this slide a few months ago, so I don't know if the current patch is still solving the issue, but okay, when I wrote it, it was working fine. A lot of local privilege escalation scenarios still present, I'm quite sure. So for us, it was integrated in our risk matrix. They say, okay, but on a Windows system, LP, it's common. Just have to wait each month for the patch Tuesday, and you have some LP exploit easily. So that's it. If you have any question, if you like to show me your VPN configuration, I can help you to detect if the configuration is well applied, because some stuff has fixed by configuration, but didn't see any real, documents saying you have to apply this hardened configuration to be safe. So maybe some of you are at risk. Sorry to present that. So any question?
Yep. I'll repeat the question. Questions?
Well, first, thank you very much for this very good presentation. This one is just for fun. Are you able now to get some discount from Palo Alto for the work you're doing for themselves?
So, sorry,
Are you able to get some discount on Palo Alto products? They should, because you did the work for them. It's something
we try to push, because for the fun fact, the project team come to us in January 2024 and say, we are complete our project, and we will go live in 2 weeks just to validate the assessment. But for sure, you will not find anything, etc.
You, it would make sense.
Yeah, for sure, because they say Palo Alto is it's a leader on networks, equipment, etc., etc. But the go live what happened 1 month or 2 months ago. So we try, in fact, for in our red team to try to be in advance. So, for example, Maxime try to use Palo Alto's VPN client before signing any contract. Come to us, say, you can check briefly the security, and we can see it's not a exhaustive pen test, but we can smell a bad thing. So no, we don't. The contract was already signed, so no discount.
Any more questions? No. Thanks a lot.
Thank you.